Alright, Lesson 16, the computation of the slope of a non-vertical line. Throughout this lesson we use the phrase rate of change in addition to slope. The goal is for us to know that these are references to the same thing with respect to the graph of a line. At this point in our learning, the phrases rate of change and slope are interchangeable, but it could be said that rate of change refers to constant rate problems where time is involved. For example, the rate of change over time. The points P, which is made up of P sub 1 and P sub 2, and R, which is made up of R sub 1 and R sub 2, are used throughout the lesson in order to make it clear that we are looking at two distinct points. When considering what this looks like in the formula, it should be clear that distinguishing the points by using different letters will clarify for us that we, in fact, have two distinct points. There are several ways of representing the slope formula, each of which has merit. And some of these you might recognize. So the slope is the difference between P sub 2 minus R sub 2 and P sub 1 minus R sub 1. Or you could do it the other way, R sub 2 minus P sub 2, R sub 1 minus P sub 1. You might have heard of the slope as the rise over the run, or you might have heard of the slope as the difference in the y values over the difference in the x values. No matter how slope is represented, it should result in the same value for a given line. So let's take a look at example 1. Using what you've learned in the last lesson, determine the slope of the line with the following graph on your lesson worksheet. When you're done, continue the video. Alright, you should have come up with the slope of the line being 3. Alright, now go ahead and do example 2. When you are done, continue the video. Alright, so you should have finished example 2, and you would have figured that the slope of this line is at 2. So now let's take a look at example 3. What is different about this line compared to the last two examples? Well, this time if we choose 2 points on the line that have a horizontal distance at 1, we cannot precisely determine the slope of the line because the vertical change is not an integer. It is some fractional amount. So make a conjecture about how do you think you could find the slope of this line. Go ahead and make an educated guess and put it off to the side, and we'll see if it is correct. Alright, so in the last lesson we found a number that described the slope or rate of change of a line. In each instance we are looking at a special case of slope because the horizontal distance between the 2 points used to determine the slope, P and Q, was always 1. Since the horizontal distance was 1, the difference between the y-coordinates of the points Q and R is equal to the slope or rate of change. For example, in the following graph, we thought of point Q as 0 on a vertical number line and noted how many units point R was from point Q, which was right here. So we made sure that the length of PQ was 1 unit, and that way the length of QR told us what the slope is. Also in the last lesson we found that the unit rate of a problem was equal to the slope. Using that knowledge, we can say that the slope or rate of change of a line is equal to m over the distance between Q and R over the distance between P and Q. Now the task is to determine the rate of change of a non-vertical line when the distance between points P and Q is a number other than 1. We can use what we know already to guide our thinking. So let's take a closer look at example 2. There are several points on the line with integer coordinates that we could use to help us determine the slope of the line. So I've marked them here, and some of them might look like they're a little bit off, but that's just inherent of the program. But anywhere where the slope line intersects two grid lines, it will give us an integer coordinate. So we have several to choose from. Recall that we want to select points with integer coordinates because our calculation of slope will be simpler. In each instance, from one point to the next, we have a horizontal distance of 1 unit noted by the red segment, which is right here. So a horizontal distance of 1 unit, 1 unit, and 1 unit. And the difference of the y values between the 2 points, which is a distance of 2. So for every 1 unit, we have a distance of 2 noted by the blue segments here. So 2 units, 2 units, and 2 units. So when we compare the change in the y values to the change in the x values, we have a ratio of 2 to 1, which is equal to the slope of the line. So here is 2 to 1, this would be 2 to 1, and this would be 2 to 1. So it doesn't matter which one. It's always 2 to 1. So each of the slope triangles shown have the ratio of 2 to 1. Using the same line, let's look at a different pair of slope triangles. How about if we compare this point to this point? Well, now we have a unit of 2, or a distance of 2 between going horizontally, but now vertically our distance is 4. So what is the ratio of the larger slope triangle? Well, the ratio of the larger slope triangle is 4 to 2. But what do you notice about the ratio of the smaller slope triangle and the ratio of the larger slope triangle? The ratios are equivalent because 2 over 1 is equal to 4 over 2, which is still equal to 2. So we have worked with triangles before where the ratios of corresponding sides were equal. We called them similar triangles. Are the slope triangles in this diagram similar, and how do you know? Well, they are. The triangles are similar by the AA criterion. Each triangle has a right angle at the intersection of the blue and red segments, and both triangles have a common angle, the angle formed by the red segment and the line itself. So when we have similar triangles, we know that the ratios of corresponding side lengths must be equal. That is the reason that both of the slope triangles result in the same number for slope. Notice that we still got the number correct for the slope of the line even though the points chosen did not have a horizontal distance of 1. We can now find the slope of a line given any 2 points on the line. The horizontal distance between the points does not have to be 1. So now let's look again at example 3. We did not have a strategy for finding slope before, but we do now. What do you think the slope of this line is? And explain. Well, the slope of this line is 2/3. So if we find common integer intersections and points, then what we can do is we find the distance between 2 points. In this case, we have 3, a horizontal distance of 3, and a vertical distance of 2. Or we could have picked the distance between these 2 points, which again is a horizontal distance of 3 and a vertical distance of 2. Or you could have picked between this point and this point, which again, if these are 2 to 3, then this is a horizontal distance of 9 and a vertical distance of 6. And if you notice, 2 to 3 is the same as 6 to 9 because 6 over 9 is reduced to 2/3. It doesn't matter which points you choose, whether it be the small triangle or a larger triangle. The triangles are similar because the corresponding sides are proportional and the ratios are equal. All right, complete the exercise and then continue the video to check your answer. All right, you should be done with the exercise. So for part A, select any 2 points on the line and label them as P and R. Well, they've decided on these 2 points. You could have picked several different points to choose from, and some sample points have been labeled on the graph. And then it asks to find the slope of this line using many different points as you can, identify the points, and show your work. So obviously yours will vary, but the slope should always be 2. And you could have picked 0, 5, negative 1, 3, negative 2, 1, negative 3, negative 1, negative 4, negative 3, and negative 5, negative 5. So any 2 points would have still given you the slope of 2. All right, so now these need to be written in your journal. And you can sketch these out. So we want to show that the slope of a non-vertical line L can be found using any 2 points P and R on the line. So we have a line, we have a point P and a point R, and again that's going to help us formulate a new point Q. Suppose we have a point P, which is P sub 1 and P sub 2. P sub 1 meaning the x-coordinate and P sub 2 is the y-coordinate. And if that's the case, then we also identify point Q and point R using the same method, R sub 1, R sub 2, and Q sub 1, Q sub 2. So then that means we can claim that the slope of the line M of line L is the distance of QR over PQ. So from the last lesson, we found that the length of the segment QR, by looking at the y-coordinate, without having to translate, we can find the length of segment QR by finding the difference between the y-coordinates of points R and Q, which is the vertical distance. Similarly, we can find the length of segment PQ by finding the difference between the x-coordinates of P and Q, which is the horizontal distance. So therefore, we can claim that the length of QR is the difference between Q sub 2 and R sub 2, and the length of PQ is the difference between P sub 1 and Q sub 1. We would like to remove any reference to coordinates of Q, as it is not a point on our line. So the line that we're talking about, line L, Q is not on that line, so is there any way we can get rid of referring to point Q? So we can do this by looking more closely at the coordinates of Q and consider the following concrete example. So let's say that point P is 1, 2, and point R is 6, 4, and therefore point Q would have to be 6, 2. So what do you notice about the y-coordinates of point P and Q? So look at the y-coordinates of P and the y-coordinate of Q. You should see that the y-coordinates are both the same. They are 2. Here's 2 and 2. So that means that Q sub 2 is equal to P sub 2. Okay? So what do you notice about the x-coordinates of R and Q? Look at the x-coordinate of R. Look at the x-coordinate of Q. And you should notice that the x-coordinates of R and Q are the same. They are 6. So if that's the case, then Q sub 1 is equal to R sub 1. Therefore, we can do some substitution. Well, if we know that the slope is the distance between Q and R and P and Q, and we can also say that it's the difference between Q sub 2 and R sub 2 and P sub 1 and Q sub 1. Well, we just said Q sub 2 is the same as P sub 2, so we're going to substitute Q sub 2 with P sub 2. We also said that Q sub 1 is equal to R sub 1, so we're going to take Q sub 1 and replace it with R sub 1. So now we have totally gotten rid of any reference to Q by replacing it with R and P. So then we claim that the slope can be calculated regardless of the choice of points. Also, we have discovered something that we call the slope formula. With the formula for slope, or rate of change, M is equal to the difference between P sub 2 and R sub 2 over the difference between P sub 1 and R sub 1. The slope of a line can be found using any 2 points P and R on a line, and we can forget using Q. So try to translate the slope formula into your own words. how is what we've done translated into words that you could use yourself? You might have heard that slope can be referred to as the rise over the run. All right, suppose we are given a horizontal line. So here we have a line, and P and R are on the line, and this line is horizontal. So based on our work in the last lesson, what do we expect the slope of this line to be? Well, hopefully you said the slope should be 0, because if we go 1 unit to the right of P and identify a vertical difference between that point and point R, there is no difference, therefore the slope is 0. So if we move, if this is considered 1 unit, well, if we move 1 unit, there is no vertical difference, so therefore it's 0. So as before, the coordinates of points P and R are represented as P sub 1, P sub 2, and R sub 1, R sub 2. Since this is a horizontal line, what do we know about the y coordinates of each point? Well, the horizontal lines on a graph of linear equations are in the form of y equals c, where the y value does not change. Therefore, P sub 2 is equal to R sub 2. And by using the slope formula, if P sub 2 minus R sub 2, whatever that is equal to 0, P sub 1 minus R sub 1 would be the same, whatever that distance is, the horizontal distance. So therefore, 0 over, doesn't matter what the coordinates are or what the length is, it's still going to be 0. So the slope of a horizontal line is 0 as expected, regardless of what the value of the horizontal change. Now for a general case, we want to show that we can choose any 2 points P and R to find slope, not just a point like R sub or R prime, where we have a fixed horizontal distance at 1. So consider the diagram below, and you might want to sketch this out. So we have our points P, R, and Q, and again, we don't know our distance between P and Q, but let's say we identify specifically that the distance between Q and, or P and Q prime is going to be 1. Then therefore, the distance between P and R sub prime is going to be our slope. So now that we have a situation where point Q is an unknown distance from point P, we know that if the triangle P, Q prime, R prime is similar to the triangle PQR, then the ratio of corresponding sides will be equal, and the ratios are equal to the slope of the line L. So our triangle P, Q prime, R prime, and triangle P, Q, R similar? Explain. Well, you should have said yes, the triangles are similar because both triangles have a common angle, which is angle RPQ, which is here, R, P, and Q. And both triangles have a right angle, which would be R prime, Q prime, P, which is right here, R prime, Q prime, P, and R, Q, P. So therefore, by the AA criterion, this triangle, the smaller triangle, is similar to the larger triangle. So now we want to do is find a way to express this information in a formula. Because we have similar triangles, we know the following: that the length of R prime Q prime is proportional to RQ, that the length of PQ prime is proportional to PQ, and that the length of PR prime is proportional to PR. And the reason of that is because we have a scale factor of R. So based on our previous knowledge, we know that if R prime Q prime is equal to M and PQ prime is equal to 1, then by substitution we have, again, we replace the RQ or R prime Q prime with M, and we replace the PQ prime with 1. Now, using cross multiplication, we would, or in this case, you could have used cross multiplication, or we can just multiply by the reciprocal of RQ, which would be, if this is 1 over RQ, then the reciprocal would be RQ. Well, that would cancel that out and leave m over 1, and that would mean that we multiply this side by RQ, which means the 1 is replaced by RQ. Well, m over 1 is m, so therefore our slope is the same as RQ over PQ. Well, based on our earlier work, we know that the length of RQ is the same as the difference between P sub 2 and R sub 2, and PQ is the difference between P sub 1 and R sub 1. So therefore, we can substitute our coordinates in for our length, and that tells us that the slope of the line can be computed using any 2 points. So this is the proof that shows that it doesn't matter what points we're using, we still end up by using the difference of the y coordinates over the difference of the x coordinates. So, to wrap it up, we know that the slope of a line can be calculated using any 2 points on the line because of what we know about similar triangles. And slope is referred to as the difference in the y values compared to the difference in the x values, or as the height compared to the base of the slope triangle, or as rise over run. And we know that the formula to calculate slope is m is equal to the difference of the x or the y values over the difference in the x values, where points P sub 1, P sub 2, and R sub 1, R sub 2 are 2 points on a line. All right, we'll see you in class.